is a point, or is a function where every point on it is the same distance from some fixed line, called the directrix, and some other point called the focus. Here's my flag. So by another similar argument, guys, we would say that this, again, and we're talking about the vertical distance down, okay, in terms of perpendicular. This distance, if I drew this perfectly, should be equal to this distance.
Wait, which line? The dotted line or the line?
The line lines.
Okay.
The two black lines, if this was a perfect parabola, and we were to take a ruler and measure it, would be the exact same length. Okay? Now, in terms of just some more characteristics to build this up a bit, let me tell you this, okay? The vertex, remember how yesterday we said that circles don't have vertices? Circles have what? What's their, like, defining point? It's not the vertex, but it's the center. Well, now a parabola doesn't have a center, it has a vertex. So the vertex is always halfway between B/W, between the focus and the directrix. Again, I'm doing a lot of very sort of general teaching right now, meaning like very abstract. There are no numbers. I would never have you recreate this picture. I would never have you write the definition from scratch, but I think there's some value to saying, okay, not just here's a parabola, graph it, okay, fine. Trying to then tie it back to all this general stuff. Okay? Now, there's a couple more things I need to tell you before we look at what the actual function is in terms of a formula, because it's not just your regular y equals x squared. It's similar to it, but it's not just that. Ideally would like to have another color. Let's do orange. This distance from the focus to the vertex, and synonymously, meaning likewise, from the vertex down to the directrix, what we just said in blue has to be the same, right? Because if the vertex is the midpoint, well then the distance from F to V, and from V to D, right, the directrix has to be the same. That has a specific distance name, whose name is P. Why it's P, I have no idea. That's just the letter that they chose. Okay. The reason I need to put this letter up here is because it's in the formula. It's no longer just y equals x squared. There's something else that goes on. Okay, so now let me give you the actual formulas. Okay, so from here. So let's just say, sort of like we did yesterday, like when it's centered at the origin, we're certainly not going to do off-center today. That needs its own day. These are not like circles. They take a little more oomph, a little more finesse to get used to. So let's just get this called when centered at the origin. Okay, when centered at the origin. Here are the equations. Okay. The first one is y equals 1 over 4px squared. What? 1 over 4px squared. Now this should look maybe somewhat familiar. We're certainly used to seeing a function whose name is y. We're certainly then, if it's parabolic, used to seeing a function who equals x squared. But this 4p business, that should seem a little shaky. What does that mean?
Is it for each side? Like, there's two p's on that side?
Yes, well, yeah, these are going to be the same p. There are two of them, but the distance is the same.
X squared or the whole 1 4p?
Just the x squared, yes. Okay. Okay, and then what I want to do is sort of informally, like in very non-math, non-universal math lingo, so basically this is a singerism, tell you how I like to think of this. I like to think of this as, so I'm going to put it in quotes, it hugs the y-axis. What do you think I mean by it hugs it?
It stays close to it?
Stays close to it. Could be that. What does it mean to give a hug to somebody? You do what with your arms?
Surround.
Around it, okay? So parabolas whose names are y equals are going to sort of center around or hug whatever variable is not getting squared, right? And you know that from Algebra 1. If you have the graph y equals x squared, this is the graph that goes up like this. It hugs y. Yeah.
Is this like an entire, like, are we graphing everything?
Today, no. We're not even going to do graphing today. We're just going to do EOPs. Yeah. Yesterday was EOCs, now EOPs.
I'm really excited.
Okay, couple of other things about this, okay? This will open up, right? Meaning look like this. Look like one of your regular favorite parabolas. Will open up if P is greater than, what do you think? 0. It's positive. That should sort of make sense to you. I mean, think of just like a line. The line y equals 2x versus the line y equals negative 2x. One goes down, one goes up. So, shocking, it's going to open down. Or you could say frown or whatever you want. If P is less. So far, folks, with the exception of this 1 over 4p thing,
Yeah, what if P is 0?
well, then it's not a parabola.
Oh.
It's a good question. If this distance is 0, then there's no focus and then there's no directrix. And it's just a point.
Just why?
So that's kind of interesting. Because then, when I think about it, regardless of what x is, this whole thing is going to go to 0.
So it's just.
So it's just a point. It's just a location, I guess. Now, here's where I'm trying to answer what you were asking for. Here's this new thing. Okay? This new thing is now going to look very odd. It's going to look like x equals 1 over 4 py squared. That is something we've never seen before. You've never seen a parabola whose name is like x equals 4y squared. Sounds similar to what you have seen. You've seen y equals 4x squared. You've not seen x equals 4y squared. That's different. So, again, what we're going to say here in sort of very Mr. Singer language.
We've seen y's, x equals y, something like that.
Can you say what?
We've seen something where x equals something y.
Sure, but not as a graph. I've never had you plot that.
Oh.
So, what this is going to do is it's going to hug the, obviously, x. Okay? These are your sideways parabolas. This is the new stuff. This is sort of like why we're here. Right? One on the top maybe looks weird because of the 4p, but we've technically seen it before. This is brand new. Our options, folks, are no longer open up or open down. What do you think they are?
Open right or open?
Great. They're opening left or they're opening right. It's going to be intuitive, though. That's a nice thing. Remember how sometimes it's backwards, where like if you take the h and you have to make it negative, or if it's negative 4, that really means it's moving to the right 4. How that can be annoying. This is very intuitive. It's going to open right, meaning towards positive. Shocking if p is greater than 0. That means this way. It's going to sort of go away from you. Likewise, it's going to open up to the left. It's going to open left if p. Again, guys, I just want to remind you as we're going here that these formulas you don't need to memorize. You just need to know which one is which and how to recognize it. Okay? Recognize and memorize are not the same thing. Okay? Alright. Anything I can do for you, question-wise, so far? If this is troubling for you, don't lose sleep over it. It's not worth it. This was just to sort of show you in a very, very abstract sense what a parabola is. But you don't need to be able to recreate that.